Okay, so question number 5. Assign formal charges to each of the atoms in the nitrate ion NO3-. So first, let's draw out the Lewis structure for the nitrate ion. We need to first calculate the total number of valence electrons for this ion. So nitrogen has 5, oxygen has 6, and we have 3 oxygen atoms, so we multiply this by 3. And since we have an overall negative charge, we need to add an additional electron. And if we were to add this all up, we get a total of 24 valence electrons. So now let's draw a skeletal structure where we have our nitrogen with a single bond to all of our oxygens. If we were to draw in all of the lone pairs, then our 24 electrons would be fulfilled. However, nitrogen doesn't have a full octet. So we need to make one of these have a double bond, like so. So now we have a Lewis structure for NO3. Oh, accidentally exited. Let me just go back to my page. Okay, anyways, we have our first Lewis structure, but we also need to assign the formal charges of each of these atoms. So the equation for formal charge is equal to the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. Okay, so now let's calculate the formal charge of a single bonded oxygen. Oxygen has 6 valence electrons, and there are 6 non-bonding electrons, so in the form of the lone pairs, and there's just a single bond that contains 2 bonding electrons, so we divide that by 2 and get a formal charge equal to -1. So we can draw these 2 oxygens having a -1 formal charge. So now let's calculate the formal charge of the oxygen that is double bonded. Again, there are 6 valence electrons. This time there are 4 non-bonding electrons, and there are 2 bonds to the oxygen, so we have 4 bonding electrons divided by 2. So 6 minus 4 minus 2 is 0. So our double bonded oxygen is just neutral. And lastly, let's calculate the formal charge on nitrogen. Nitrogen has 5 valence electrons. There are 0 non-bonding electrons, so there are no lone pairs. And also the nitrogen has 4 bonds to it. So we have 8 bonding electrons divided by 2. So 5 minus 0 minus 4 is +1. So this makes our nitrogen positively charged. So if we were to calculate the overall charge of the ion, we can double check overall charge. We have -1, -1, +1, which makes it an overall -1 charge. And we can also show the resonance structures of this ion as well. So our first oxygen can have the double bond. Or the last oxygen can have the double bond as well. Okay, so these are the 3 resonance structures of the nitrate ion. And the junior tutor said that they calculated the total number of valence electrons, so they have 5 plus 18 plus 1 to get 24. The Lewis structure of nitrate ion is given as -1. Okay, so it's down here. And they also included the equation for formal charge, which is equal to the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. So they calculated it. I feel like the images might be a little misplaced, but they have the example showing the formal charge of the double bonded oxygen, which should be 0. Nitrogens was +1, and oxygens were, the single bonded oxygens were -1. So this solution is correct.